and then also the first presentation done entirely in personal sketch drawings. So welcome to the stage, Luke.
So at the end of the first Harry Potter book, this guy has been messing with Harry the whole time, and he realizes it's Professor Quirrell. But then Quirrell takes his hat off, and on the back of his head, there's chillin' Voldemort, the way more evil bad guy. Climate change, like Quirrell, also has two faces. One really visible one, all the cars and trucks and power plants that we see every day, and an invisible one, which is Voldemort, all the gases we've emitted since the beginning of the Industrial Revolution that are just parked up in the atmosphere. So why is Voldemort a problem? He's a problem because the carbon cycle is completely overloaded right now. So there are decades of heat-trapping gas up in the atmosphere where even if we went to zero emissions today, they're going to stay there and warm the planet for years and years to come. And this is happening because, so the carbon cycle used to be in harmony. It used to be really happy. So all the CO2 and gases that the Earth would naturally emit were sustainably absorbed by the forests and oceans and other sinks for carbon. But we've jacked it up. So today, we've been digging up all the fossil fuels that the Earth had locked away for millions and millions of years, and we're burning them in a really short period of time. And so all that extra gas that the Earth can absorb is hanging out in the atmosphere. So what do? Who's seen Spaceballs? We got to vacuum it out of the atmosphere. So the way you do this is with what are called negative carbon emission technologies. And they're essentially things that resequester CO2 out of the atmosphere and keep them down here on Earth so that we can get that heat-trapping gas out of the atmosphere. You might be thinking trees do this, and you're right, trees do this. And trees do lots of other great things like purify water and stabilize soil. But negative carbon emission technologies can actually do the carbon sequestration part way better than trees can. And a synthetic tree that I'm going to talk about comes from Arizona State University's Center for Negative Carbon Emissions. There's a guy named Klaus Lackner, and he and his team are currently developing synthetic trees that can absorb 1,000 times as much CO2 out of the air as a tree can in the same amount of space. And their material is a plasticky material with tiny resin beads in it that have a very high affinity for CO2. And right now they're currently researching what kinds of designs are going to be the most effective. And very importantly about their technology, when you put water on it, it releases the CO2 gas that it captures from the atmosphere. And you can keep that in a contained environment down here on Earth and do stuff with it. And so they're about $10 to $20 million and many years away from a prototype, but the product they're proposing looks something like a shipping container. And Lackner says that to balance the world's current emissions, we would need 100 million shipping containers. So let's take a second and freak out about that. Because that is so many shipping containers to get so much CO2 out of the atmosphere. All right, so everybody freak out. All right, we are done freaking out. So what do you do with all the CO2 you capture? Because we got to do something with it. Well, two kind of current proposals are, one, to turn it into a solid and bury it. That is technically feasible. Another thing is to do what's called enhanced oil recovery, where you pump CO2 underground and get more oil out of the ground. And there's a market for that, so there's an economy there. I'm really interested in what's called an XPrize, and this is an organization that gives millions and millions of dollars to companies that are cracking the world's toughest problems. And there's currently a carbon XPrize that's going to give $20 million to a company that comes up with a way to make really useful stuff out of captured CO2. And the 25 semifinalists currently, the projects done in 2020, are proposing things like concrete and plastic and animal feed and even shoes made out of CO2. So this is really exciting stuff. Let's look at one example, plastic. So if I have plastic that's made out of CO2, I'm not only making a problem less bad by pulling CO2 out of the air, but I'm replacing another product that's part of the problem because plastic's petroleum-based. Okay. Just because we're going to be able to sequester CO2 out of the air does not mean we should slow down on fighting Quirrell. We have to decarbonize power generation and we have to decarbonize transportation. This should not enable a delay in getting to renewable energy and clean transportation. So we have to go full throttle ahead on fighting Quirrell and Voldemort. And the IPCC says that in order to meet the Paris Climate Accord's goals, we'll need to do both of these things. We'll need decarbonization and negative emissions technologies. So I know this can feel like a really big, scary problem, but the world is making progress. And this is something we can beat. So talk about it. Talk about it with your friends and family, and most importantly, stay positive. So 2 things I'm going to ask you to do. 1, donate to research. Donating to research is really important. Every dollar counts. As I mentioned earlier, Lackner and his team are $10 to $20 million away. That might seem like a lot, but if a lot of people help, it's not. And then one day, buy some shoes made out of CO2.